This session is based on this documentation, which is the onboarding guidelines document. And recently we added a new section, which is the VNF onboarding walkthrough, which is an example of a specific VNF. The next EPC VNF is an open source 4G packet core. And what we have done here is go through all the recommendation, the procedures documented in the guide, and apply them to a VNF so that you can see how we can build a VNF package from scratch and test it out. Okay, so before jumping into the details and starting with a hands-on, let me clarify that all of this is being done over a specific environment, which is the onboarding labs at Etsy. As many of you know, Etsy has an OpenStack environment, which is used for many things, for Hackfests, for plug tests, for CI/CD in OSM. And recently we added some tenants for VNF providers that are interested in building their VNF packages in here. So what we provide as a task force is a tenant for the VNF provider and an OSM instance, which is shared among providers, but with different OSM tenants using the RBAC feature. So every VNF provider has access to OSM through web and SSH, which is also SSH. The operating system has also all the users, specific users for each provider. And then you can have a tenant in the OpenStack environment of Etsy so that you can leverage this lab to build your VNF package. And we track the progress of how you are moving forward with your package. If you already designed the package, if you already have day 0 prepared, day 1, day 2, and at the end of this process, if you achieve to build a complete VNF package, then we can enable it for being published at the catalog we are building at the main OSM website. Okay, so I'm using this same environment to go through this onboarding. So first of all, as the onboarding, as the guidelines suggest, when you are building a VNF package, you should gather all the requirements. So if we see the guidelines, we specify here which requirements are the ones you should focus on. If you need some performance features, how many CPUs, how much memory, the topology of your VNF, etc. So that's what we are gathering here in the example. So in particular for this VNF, it is built of 2 VDUs, S gateway, P gateway, and MME in the single VDU or VM, and an HSS in another VDU. Okay. Then for the first VDU, we need 2 CPUs, 4 gigs of RAM, 10 gigs of storage, and we need some EPA features like CPU pinning, huge pages, and SRIOV in the data plane interfaces. And for HSS, we just need 1 CPU, basic stuff. This is the design of the VNF. It's very important for you if you want to build a VNF to start by drawing the VNF in such a structure like this, where you can see the interfaces, when you can see if what connection points are you exposing to for it to be part of a network service together with other VNFs potentially. It's also important to identify if you have any internal VLD or network, which is the one you as VNF provider care of or would like to have more control. This VLD or network would not depend on the infrastructure, not much on the infrastructure, but on the requirements that your VNF has. So it's important to make a difference between internal VLD and external VLD that is part of the external infrastructure you would connect to. Okay, so then it's important to identify which are your interfaces and the names of your connection points, external connection points like this SP Gateway MME S1, or internal connection points like this SPGW MME S6A. This would be an internal connection point. This S6A would be an internal VLD, which interconnects your SP Gateway with the HSS. So it's important to have this drawing available. Okay, then, well, all of these are, first of all, day zero requirements. I forgot to tell you what day zero is all about. In this, with these requirements you gather, what you want is to be able to instantiate your VNF and to be able to manage it. So for instantiating your VNF, you need to know how it looks like, what are the main components, what are the requirements to instantiate it, how it would connect to the external networks and internally, and also how you would manage it. And in this case, in particular, for this example, we are passing through Cloud Init a host name and a password. And if you see here, we are leveraging a feature of OSM which lets you parameterize the Cloud Init so that we can pass the password at instantiation time. Okay. So with all of these requirements you see here, which are the typical ones that any VNF provider, any VNF vendor provides, you can instantiate the VNF and be able to log in order to manage it. So we are ready for, with this, we can build a package that achieves day zero, that is instantiation. If we want to go further and configure the VNF for it to actually do something after being just instantiated, we need to specify how the VMs or the components need to be configured for providing the services. So in this example, we are saying that for this VNF to be considered ready for receiving subscribers, for example, this packet core, it needs to enable some configurations. All the value of the higher layers of management orchestration, which are the NFBO, the VNF manager, are in here, right? What you can automate beyond instantiation. So it's very important to prepare a package that automatically configures the VNF so that it's ready to provide services. So in this particular example, we are just taking some simple configurations like enabling interfaces. For example, in the SPG gateway and MME, it requires you to enable the interfaces that are not the management interface. And it requires you to replace some parameters, for example, the HSS IP address and the SP gateway IP address of the S6 interface in a file named mme.com. Okay, so it needs you to somehow replace those parameters, HSS IP and SP gateway IP, in the mme.conf file. Since this particular VNF does not expose any API to do so, we are configuring it through SSH. So, and it's based on Ubuntu Bionic image. So these are the recommended commands that you could run to automate these requirements. And finally, the VNF asks you to, or needs you to restart the MME daemon, okay, after replacing these variables. A similar thing for HSS. It requires you to enable an interface, replace some variables, in particular the HSS IP and the SP gateway IP address, and restarting the HSS daemon. Okay, so it's important for you as a VNF provider to specify these configurations that you would need. It could be API calls, it could be Python scripts, it could be anything that you need to start the VNF services, and consider that the VNF is ready for providing its basic services. Okay, so that's day one, and in our package we should figure a way to configure this. In day two, we are just enabling an operation that would make sense for this VNF. In the example, we are adding routes, so we are letting the operator add additional static routes to the SP gateway. This is just an example. But imagine that this is what you would like to expose to the operator, a way of adding additional routes. And also, as day two requirement, we need the VNF to be monitored at CPU and memory level. Okay. So all of these requirements, we need to achieve them in the VNF package. Okay, so I'm using a VM where OSM happens to be installed. You don't need OSM. I mean, you don't need it to build your package. You don't specifically need OSM. But we will be using some tools that OSM provides to build a package. In particular, we are using a tool that is contained in a DevOps repo of OSM, which is the ValidDescriptor package tool. Okay, so first of all, I'm preparing a directory for my VNF packages. I will not clone the DevOps because I have it already here. Otherwise, you would need to clone it. And then access the tools of the DevOps repo. Now we are using the ValidDescriptor package tool. It is documented in more detail if you visit the onboarding guidelines document in the other sections. Day 0, for example, which we are now. It documents all the options of this tool. But in this walkthrough, we will customize it to our specific needs. So what we need is a VNF descriptor that puts the packages in the VPC directory. It specifies a particular image, which is already present in my Vim. It specifies the number of CPU, memory, storage, the number of interfaces besides the management interface, the vendor, and it specifies that we will create a network service descriptor as well, just to be able to test this VNF in OSM. And it gives it a name, of course, which we will use VEPC. Okay, so I will run this tool. So we can safely ignore those warnings. And inside my directory, we will see two folders, VEPC NSD and the VEPC VNFD. The one we should care the most about is the VNFD, because there is where our VNF descriptor resides, together with some other things like Cloud Init, charms, and other things. Okay, and it also provides the packaged versions, I mean, the compressed files of these folders. And as we can see here, thanks, is that the basic attributes we gave to the tool. So one VDU with a name that was put by the tool, actually. The flavor that we're using, I mean, how many CPUs, how much memory, how much storage. We can see here 4 interfaces. We specified 3 interfaces, but the tool provides additional interfaces to the management or the first one. Okay, so It starts with 1, and if you want more, you put interfaces, in this case 3. So we have 4. All of these are configured as external interfaces. I mean, interfaces that will end up being referenced by a network service, for example. So they all map to connection points. These are the connection points that are exposed by the VNF to the network service. And it documents how you would configure, for example, UU charms for day one operations. Okay, so this is where we start. And what we would like to do with this descriptor is further customize it, right? So I'm naming my VDU in a different way, because for me, for example, it's easier to refer to this VDU as the SP Gateway MME. Then in the interfaces, I would like to specify the connection points with a different name too, because these names are not exactly describing what the interface is, the interface role in my VNF. So I prefer to keep I keep the interface name, but I'm changing the connection point name so that I can refer to this interface in a way that is more familiar for my VNF. Okay. Okay. Then we have another VDU. So we can take this first VDU as an example and create our additional VDU. In this case, is 1. You can create as many VDUs as you want. I'm going to delete these comments. I prefer this to be cleaner. So let me delete those. I will add the other VDU, which is the HSS. So it has a name, the flavor, the image it will use, and the interfaces with the names I want. Okay, so we have this video. We added in the list of VDUs. Sorry, I deleted something that I didn't want to. Let me undo just in case. Okay. Okay, so we have the VDU list with the first VDU and the new VDU that I'm adding now, which is the HSS. Let me delete this. Okay, so now we see that we have 4 external interfaces in the first VDU and 2 in the second VDU. But as our design specified, we need one of them to be internal. And with the internal connection points and with the internal VLD that is under the control of my VNF package. So let me confirm that I'm recording. Yes. So what we do is change this external interface, which is the S6A interface or VLD. I mean, the connection point that connects to the VLD called S6A, it will be internal, okay? And it won't have an external connection point, but will have an internal connection point. And I will do so in both VDUs, the corresponding interfaces. So let me change this. In the first one and in the second one. Since we have an internal interface, now we have to take care of the internal connection points, and we have to take care of the internal VLD inside our descriptor of the VNF. This is not something that we want to delegate to a network service, right? So we add the internal connection points, which we configure or we add at the VDU level. So this VDU has an internal connection point called SPGWMME S6A, and this other VNF or VDU, sorry, exposes its own internal connection point. And the way we connect them is through an internal VLD, which is global for the VNF. So it's not at the VDU level, but it's at the global level of the VNF. Okay, so we have this internal VLD that connects the S6A interface of the SPG gateway MME and the HSS. Okay, it connects them together. So it instructs the infrastructure to interconnect these two connection points together. That's the way we interconnect two VDUs through an internal VLD. Okay, so now we need to clean the external connection points names because they refer to the old names. So these are the connection points that we are exposing to a network service. So the management interfaces of both VDUs, and for the SP gateway, the S1 interface and the SGI interface, which are the data plane interfaces. Perfect. And then there is a section called the management interface, which is already there, which also refers to an old name. I will change it for the name of the SP gateway. In general, you need to provide a connection point that OSM can use to configure the VNF. If you don't have an element manager, for example, or a VDU that manages your whole VNF, then this VM or this connection point needs to connect to a VM that you would prefer when, or the main VNF that would contain most of the configuration of your services. In this case, I'm specifying the SP gateway. Okay. Now we can, in this sample, showing how you can further control how this internal VLD is created in the infrastructure. Since it's a network that is internal to your VNF, it does not need to be routed, or it would not conflict with infrastructure of the operator. So you can take some liberty to fix the subnet, for example, that you would use there. This is an example of if in case you want to do this, you would do it through IP profiles. So IP profiles specify a way to how you would create the subnet or the network, the VLD in the infrastructure. In here, we are defining a particular prefix for the subnet, and we are saying that DHCP is enabled, and that's it. So that's at the global level. I can put it anywhere at the global level. I mean, below VNFD. So we have an IP profile called S6A that defines that our subnet for the internal VLD will be this, 10.0.60. And then we just apply the profile to the VLD. Okay. So in this way, anytime you instantiate this VNF, it will configure this subnet in the internal VLD. Now let's take care of the EPA part. So as we saw in our requirements up here, the SP gateway needs CPU pinning, memory huge pages, and SRIOV in the S1 and SGI interfaces. I'm going to show you how this would be done. But since this VM in particular is not ready for EPA right now, we will comment that part, okay? But it would be in OSM is as simple as specifying a guest EPA section inside the VDU. So below the SP gateway VDU, I will put somewhere in here at this level next to the flavor. In my case, I would like to see it there. So here I'm putting a section called guest EPA. I'm specifying dedicated CPUs. So CPUs, the two CPUs that I'm assigning to SP gateway will be pinned, and I'm requesting a large pages for the memory. Okay, and it also requires SROV. OSM is as simple as modifying this paravirt type in the particular interfaces that you want for SROV. And when you instantiate, what OSM will do is translate all of these requirements to the calls that the VIMs need for requesting the particular SRLB interfaces and for requesting the CPU pinning and everything. But as I said before, this particular VIM is not ready for EPA, so I'm going to comment this out or change it. Okay, now finally, to be ready for day 0 packages, let's take care of the cloud init part. Okay, so I'm going to specify the names of the cloud init files I will use, and I need to put those cloud init files in the folder named cloud init inside our VPC folder. So as you see here, there is a cloud init folder that is empty, and there I need to put the contents. First of all, I'm going to specify in the descriptor the names of the cloud init files. So let me put it around here next to the image. The cloud init file for SP Gateway is SP Gateway MME init, and the cloud init file for HSS is this. Now I need the files. I already pre-created those files in another folder, so let me go for them. Put it here. So I'm going to take one of them just for you to see. This is a very basic one. We're setting a host name and we are setting a password. We will need to pass this variable at instantiation time. And same thing for the SP Gateway one. Very similar. Okay, so far we have a descriptor that takes care of most common day 0 requirements. Okay, so in day 1, we need to connect to the VNF, be able to connect to the VNF and configure it, right? For this, in OSM, we use VCA, which is basically UU. So it has a UU controller that will instantiate LXC containers that will contain a code that we can provide in our VNF package. And this code will be used to interact with the VNF as we want. So it can configure it through SSH, it can call REST APIs, it can run Ansible playbooks. It has a potential of doing basically anything that can be built with Python. So let's see, first of all, how would we specify this at our descriptor level? We have this VNF configuration block where we document the primitives or the actions that we will run automatically when the VNF is instantiated. That's what we call day 1, because as soon as it's instantiated, they will be automatically executed. So here we have the first primitive is called config. That's a mandatory one if you want to connect through SSH. So you define an SSH hostname, which is the management IP, which will be auto-populated if you provide this parameter here. Then you have the username of your VNF and the password. The password is optional because since release 6, you can omit this password and let VCA insert its keys, its SSH keys. Okay, then we have a second primitive that is the one that we would actually use to configure the VNF, which is configure SP gateway. It will pass some parameters like the SP gateway IP and the HSS IP. And then we have a third action that will be run, which is restart SP gateway. So this is these are the requirements we had for day 1, right? To configure some files based on these 2 parameters and then restarting the service. And then we have to specify the charm that we are going to use for that and give it a name. We put SP gateway charm. You can use underscores here. Okay, so let's copy this block. It's a global one and we put it, sorry. Okay, there it is. Okay, so since it's a global VNF configuration, what OSM will do is to access the global management connection point, which is specified by the management interface here. So the VNF that it will configure is the SP gateway. Okay, if we want to configure the HSS, then we would need to specify a different type of block, which is the VDU configuration. Let's see how it works. The VDU configuration block is exactly the same in content, but it needs you to define one of the interfaces of your VDU as a management interface. That's the only requirement. Okay, so for the HSS, we will say, okay, this interface would be my management interface. And now we will add, at the end of the VDU section, we will add our VDU configuration block. It's going to set the configuration for connecting from HSA through SSH. Then it will configure the HSS through replacing the files with these parameters. We will specify that later. And then it's going to restart the HSS service. And for that, it will use a charm called HSS charm. Now we need to build the charms that do the actual configuration. So for that, you need a package called a charm. I already installed it. Then, well, recommend you to use a predefined directory where you will have all your charms. Then to have some environment variables that will simplify the process. And to access the actual directory, well, you will create a charms, which is the charms layer directory. So here we will create the SP gateway charm, which is the one we referred, right? SP gateway charm. Let's do it. Please note that we are using the traditional way of building charms, which is the more flexible one. Recently, we added these proxy charm generators specifically for the Ansible case, which automate some of the steps that we are going to see here. But since it's only it has been only generated for Ansible, and we are not going to use that. And I prefer to show you the traditional way, so you have more flexibility to create any type of charm. Okay, so now we are in the folder of the SP gateway charm. We need to modify some files here. First of all, the layer YAML file. We need to make sure that it contains the layers that we need. What does this mean? It's code that is already done by the framework, and it, in particular for the VNF proxy one, it takes care of all the connectivity and the SSH connectivity to your VNF. Okay. Now the metadata contains some information about your charm, the name, and some description, maintainer, those kind of things. Okay. Then we have this actions YAML file that needs to be created. It does not exist by default. Actions.yaml. And here we will specify the actions that we expect to run in the VNF. So configure SP gateway and restart SP gateway, right? Those were our actions that were coded before in the descriptor. Configure SP gateway, restart SP gateway. The config one is not needed because it's a system one. It's expected. It's already expected to be present. Okay, so we will add this content here. I will show you what does this mean. You need to specify the name of the action and the parameters you're going to need. Now, in particular, for the configure SP gateway, we need a parameter called HSSIP, which is of type string and has a default value of 0. And the SP gateway IP, same thing. Then we have another action which is called restart SP gateway, which doesn't need any parameter. Okay, all right. Now, this part is very mechanical. We need to create a folder which is called actions. Let's do it. And inside that folder, we need to create a file for every single action that we had. So configure SP gateway needs a file that needs to have this content specifically. Okay, and it's the same content for any action. So I'm just going to paste this, copy and paste this to create that file, and then you need to make it executable. I'm going to do the same for the other action, to paste the whole thing. Now let's make sure that those files are there. There they are. Okay. Now the important part. The important part is the reactive file. The reactive file is where you define what you are going to actually do with your VNF and how you would do it. Okay, so let's edit this file. Okay, it's almost empty. What I recommend is to add these dependencies because these are the ones that we mostly use in charms. I missed this one. Then you can leave this empty action here. It is there because maybe you want to install all dependencies for your charm for your VNF. And now let's paste here the actions. So what are we doing with the configure SP gateway action? When the action configure SP gateway is executed automatically by OSM, then this function here will run. This function is taking two parameters. This is the way you would grab parameters that you feed in your descriptor. So we are feeding the HSS IP parameter and the SP gateway IP parameter, right? If we go back to the descriptor, we can see that we are feeding the descriptor with those parameters. They are not set at this time because we want to populate them at instantiation time, but they are there. So this is the way you would get those values. Then what I'm doing here is just setting a command and running the command. I'm doing that for the three interfaces I want to enable. Then I'm using the set command to replace the HSS IP variable in the mme.conf file. So this is just a Python. So whatever you can do with Python here, you can put it. But you can leverage the methods of the charms SSH proxy layer, which is, for example, feeding the charms.ssh proxy with a command, and it will take care of logging into the VNF and running the command. As you have SSH proxy, you also have SFTP for copying files, for example. And then you remove the flag. That means that you finish with that action. The other action is just the restart of a particular daemon called mmed. I will just define the command and run the command, and that's it. Okay, so here is where you can adapt your configuration to whatever you want. You can call REST APIs, you can define Ansible playbooks, whatever you can do with Python. Okay, so our charm is ready. Now let's create the same thing for the HSS charm. While I create that charm, the HSS, the same procedure, create a charm, then modify the HSS charm, then modify the layer YAML, then modify the metadata, have it ready, then create and modify the actions YAML file. It's not created, so I need to create it. With the actions that correspond to HSS. Remember, in our video configuration, we have two actions: configure HSS and restart HSS. So configure HSS and restart HSS with the parameters, if applicable. Then we create this. Then we create these files, these executable files for each action. For configure HSS, for restart HSS, and finally, we edit the reactive file. I'm missing a comment here. So reactive file HSS. First of all, I want to take care of the dependencies. And then I will add the functions. We are using similar commands for the HSS. Configure HSS, enables interface, replaces the files with the content, and then the other action restart just restarts a daemon. That's it. Okay, so the charms now need to be built and added to our VNF package, but we are leaving that for later because now we want to add day 2 operations. So what we mentioned before for day 2 was I want to, let's see the requirements. I want to be able to add routes to SP Gateway, and I want to monitor the CPU and memory. Okay. So if we want to add a route, we need to connect to it, and we will use, so we can add an action, an additional action to our existing charm. But this is, day 2 is about running actions on demand, not at instantiation time. So it's not an initial config primitive, but a config primitive. Okay, that's the difference. So I'm going to add this config primitive in the VNF configuration. And the same charm will take care of that primitive. It has a difference that the parameters here take default values, not values, not the definite value, because you can change this value when you run the action. Okay. So I'm going to add this primitive named add route, which takes an external prefix and an next hop and adds a static route based on those parameters. So let's do the changes in our charm folder. Let's go back to the charm folder of the SP Gateway. We are there. Modify the action file because we added an action. And it will be add route. Add route with its parameters. Then we add this executable for the action. Let's confirm that it's there. It is there. And finally, the important part, the reactive file. We need another action, which is called add route. So right here. And it just uses this route add command, takes the prefix, which is the one we defined at the descriptor, takes the next hop, and that's it. Obviously, this is on demand, so we can provide these parameters when we run the action. Okay. So now the other part of our day 2 operations is monitoring. But before that, our charms are ready, so we can build them. Let's go into into each folder and just run charm build. It will build a charm based on all your specifications, and then we copy that result, which is in the builds folder. You copy that complete folder. That's why I'm putting this recursive flag here, to the charms folder of our VNF. So I'm going to copy it. That's it. And now let's go to the other charm, which is also ready. Build it. And then we're going to copy it in the same way. Okay, let's copy it. Now back to our folder, VEPC. Let's see if the charms are there. Charms. Okay, we have the build charms in there. Perfect. Now, as part of our day 2 operations, we specified that we needed to monitor CPU and memory from the infrastructure. So that's this is the way we achieve it, through NFVI metrics. At the VDU level, we want to monitor. We specify the NFV metric we want to monitor, as well as an ID for the metric. Okay, so I'm going to copy this block to the VDU that we need to monitor here. At the end of the VDU block of the SP gateway, I'm putting monitoring params, an ID of the metric, and the particular metric. This is a name that is already defined for gathering CPU metrics from the NFVI. That's it. That is through the APIs exposed by the BIM to gather these metrics. The same with memory. Okay. Other parameters, other metrics are supported, like network, for example, network packets in, packets out, and you can see more of that in the documentation of the monitoring model. Okay, so now we need to define those parameters globally. So we define them first in the VDU part, and then we define them, we refer to those globally. OSM can also gather metrics through UU charms, for example, and feed them into the system as a monitoring param. Now it is ready, our package. So let's go back to our folder. This folder here is where we have been working on, the VEPC VNFD. It has the descriptor as we want it. It has a cloud init file, or 2 cloud init files, and it has 2 charms. So that's ready. But to test it out, to instantiate it, we need a network service that uses this VNF. So we are going to build a network service that just instantiates this VNF as a standalone. Okay. For that, we have our descriptor, our NSD descriptor already built by the tool. Let's see how it looks like. There it is. And as you will see, it has the old connection points. It has some VLD names that are not that descriptive. But in general, what you need to define here is the VNFs that are part of this network service. It's just one VNF. And the VLDs, the external VLDs that you need to instantiate or to connect to, as well as which connection points, or which external connection points of which VNF will connect to each VLD. So I'm going to erase all of these and just copy what we got here, which is ready. So here you will see one VNF, which is the one we built, and 3 VLDs. A management one, which connects to an existing network called OSM Ext, and connects 2 connection points here, the management connection points of the VNF. Then we have the S1 VLD, which connects to an existing VIM network name called S1. And in particular, we are asking for a specific IP address. We can do those kind of things if we know the prefix of the subnet that is the existing one. I'm doing this just because I want to match some pre-configurations on the VMs. Okay, our network service descriptor is ready. And now we are going to use a tool inside the DevOps repo called ValidDescriptor to see if we are matching the model of OSM or if we are making any mistake. I'm going to run it from the DevOps repo into the YAML of the VNFD first. Oh, sorry. Okay, no. Okay, if it doesn't throw anything, then we are okay. But for example, if we had some attribute wrong, like I changed this ID for idea, then it will throw a warning. Okay, so it will take care of some of the most basic errors. Okay, so let's validate also our network service descriptor. Okay, it's fine. And now, since our packages are ready, let's compress these ones again. I'm just running tar over them. And I'm replacing the old tar files with a new content. And now we can create the VNFD in OSM and the NSD in OSM. Before instantiation, remember that we have some parameters to pass. We can pass them through a text, a string in our nscreate command, or we can define a file, which that's what I prefer. We can define a file named params, or named whatever you want. I'm naming it params.yaml with the content of your variables. So I'm putting the SP gateway IP, the HSS IP, for the member VNF index 1, that's the first VNF, the only we have, and I'm specifying that as additional params. So this is the format you should use. And we are passing a password too. Let's change it for OSM for me. I can change here for 30 and 40. And we are also setting some additional things at the VNF descriptor. You can do so too with this YAML file. We are setting particular IP addresses for the VNF components, for the VDU. In our internal VLD, at instantiation time, we are saying that we will force the IP address or request to the Beams IPAM these two IP addresses, 30 and 40. So in this way, we can fit our charms with the IP addresses that we are setting at the same time. Okay, this is one of the ways you have to configure your components when IP information needs to be exchanged between them. We are ready for instantiation, I guess. OSM nscreate, in this name, EPC1, the name of our network service descriptor. I'm passing the keys of this machine so that I can log in without password to the machines. And I'm passing the params as config file and using a Vim account that I have pre-configured, which is called White Cloud Admin. Let's see. So the regular way that you have to monitor how your network service is moving is through the nslist command, right? But maybe you noticed that in release 6, it takes a lot of time when you have charms. That's because the charms are created first. So we need to monitor the charms, and the way we do it in release 6 is switching first to the model that contains the charms of this particular NSD. And now we can run the UU status command, for example, to see what's going on there. It's waiting for machines. That is creating the LXCs. Each of these LXCs will contain the code we defined. You remember the reactive files and everything to be run into the VNF. So the flow is like this. It starts creating the, I put it here. Yeah. So the first thing, it creates the charms. It creates the execution environments of the charms. installs the dependencies that you need for the charms, but it does not execute any primitive because you don't have VMs yet, right? Second thing, it creates the VMs in the Vim, and when they are ready, it runs the initial config primitives, so day one. And then on demand, you can run day two primitives. Okay, that's the way it works. Let's see how it's moving. Now it's installing charm software. You can also debug this with debug log, and you see the global logs of all the charms that are running. You can also get into a particular LXC. For example, I'm interested in monitoring the charm of the HSS, which is the machine number 1. So I say UUSSH1, and I'm into the LXC that will run the charm. And from here, I can, for example, check the log of UU for this unit and with sudo, and you will see what it's doing for this particular charm, not for the global, not as a global level as in the UU debug log command. Okay, so it's just installing dependencies, and it will eventually finish, and it will try to connect through SSH, and it will fail because the VMs are not there yet. Okay, so this is a temporary state. Now we can monitor the network service here. It's creating the NSD at DRO. It's waiting for the machines. So let's go to the Vim, and there we go. We have two machines being built. We have a router 2 there, and we have the OSM machine in this tenant. So we can see it has the S1 pre-existing networks SGI, but it created one network called EPC1 S6A, which has the subnet that we defined. And we can see too the addresses 30 and 40 that will be assigned through the HCP, but we instructed, in this case, Neutron, through its IPAM to use these IP addresses in this network. So that, okay, the VMs are active. Let's see if the primitives are being run or not. Okay, it's trying to log in now. In the meantime, I would like to share with you the other part of the descriptor we defined, which is the monitoring part. So if we visit port 1991 of the OSM machine, we will access Prometheus. And this is the UI of Prometheus. And if we type in OSM, we'll see the metrics that OSM brings. You can see the status of your beam, for example. Here we have 3 beams. You can see the status of the VMs that are created at any point in time. You have a lot of VMs there. If it's 1, then it's active. And most interesting, we can see the metrics, but we don't have data points yet for the OSM CPU utilization or memory because it takes some time to gather the metrics for the particular VMs that have just booted. We are ready with the charms. So let's see now that the NS is configured. So how do we validate that it was configured? It should have run the primitives that we defined, right? So in this particular case, we need the HSS to have a established session with the SP gateway. Let's see if that's true. I will access the SP gateway, for example, through SSH. Oops. Let me try it again. Okay. I'm inside the SP gateway. The host name was defined. Let's see the netstat command with TN. No, grep with these IP addresses. No, sorry, it's 06. Okay, so we have established session between IP address 30 and 40, which is the HSS. We can also see the mme.conf file. Well, this is too much detail maybe, but it was populated with the right value that we defined live there at instantiation time. And we can see the same at the HSS. The session is established and the hss.conf file was populated with the right value. So that's the thing. Now what we can also do is to define an action, to run a day2 operation. In our case was add route. So we ran over the NS named EPC1. Well, it's not the name we put. I guess it was with capital letters. And over the first VNF, the action called add route. The parameters we can pass are these. So let's try that. I'm going to connect again to the SP gateway, show the routes. We don't have a route for the network 8, for example. So we are going to run that action for EPC1. Again, add route with the parameters external prefix 888.0/24 to the next hop 192.168.21, which is the SGI network. That's normal, that's a warning. Let's go back to the EPC. Oh, there it is. See? So that's a sample of a day2 operational configuration that you can run. It can be as complex as you want. If you installed the performance management stack in OSM, you can have access to Grafana as well, port 3000, and see whatever Prometheus shows, but in a customizable way. And well, since we have a granularity of 5 minutes for metric collection at this beam, well, CPU is taking some time, but memory is already there. This is the default dashboard for OSM. It's a sample dashboard. You can change it easily. For example, you can put here a beam status without any legend and see that it brings the beam status, the status of any beam. If you want to customize the legend, you just take one of the parameters, for example, beam account ID, and put it there, beam account ID, and there you go. Then we can, for example, put here the VM status, which is something we have, VM status, and same thing. We erase the legend to see what is bringing. Has a BDUR name. Okay, so let's put BDUR name, and we will see that it will show the names of the BDU and the status of the BDUs that are controlled by this instance of OSM. And eventually we will have a CPU here. So here in Prometheus, since it's the source of the information, then we should definitely have the average memory utilization. Okay, that's it. At the guidelines of onboarding, you will find more details. This was just the example that applies all the information that is here in the rest of the document. So please, any feedback that you have to enhance this document, to add more use cases, please feel free to ping me or to write to the mailer. We have in the VNF task force, we have a mailer which is OSM VNF omb@listsetsy.org. We have these sessions once every 2 weeks. And we have also, as I was saying before, the possibility of giving access to a tenant of OpenStack tenant, or in the future VCD tenant as well, for VNF providers that are interested in building their packages and being part of a catalog that we are building with packages that are not only instantiating the VMs, but are doing more interesting stuff like the things we have seen here. So just write an email to the mailer of the VNF onboarding task force, and we'll be glad to give access to a lab environment.